Today we are going to learn about logarithmic models and their graphs. So before we start doing any graphing, let's look at what a log is. In the most purest form, the log is the inverse of an exponential. An exponential is a function, and our functions have inverses, and the inverse that undoes the exponential is what we call a log. So these should be very familiar. These are all exponential forms. Something raised to a power yields some answer. This right here reads log base 2 of 8 is or equals 3. This is not by any means a math term, but I call it a swooshy. You start with what's the base and you swooshy towards the equal sign. So in this expression right here, 2 is my base, so I start at my 2 and I make a Nike swoosh towards the equal sign like this. So the first thing I touched was the 2. So this becomes log base 2. The next thing I went past was the 8, and finally I ended with the 3, which is what you see that I got right there. This works the same way if I want to go back to exponential form. So starting here with my log, the base is 4. So I start at my 4 and I make my swoosh towards the equal sign and around. So the first thing I touched was the 4. The 4 stays the base. 4 to the next thing I went by right here is the 0. 0th power equals 1. And the pattern continues. 12 log base 12 of 12 equals 1. Log base 12 of 12 equals 1. Log base 1/4 of 4 equals -1. Right there. So let's try a few. So the base in the first problem is 3. So make your little loop or your swooshy. So this becomes log base 3 of 81 equals 4. The base here is so my base here is a little 7. So 7 to the first power equals 7. 14 is my base. 14 to the 0th power equals 1. And the last one, start with the 1/2, the base, and swooshy towards the equal sign. So the first thing you touched was the 1/2 is the base, and then you went past the 32, and that equals -5. So now we can convert back and forth. And really, my rule of thumb is if you're in an unuseful form, go to the other form. So if I'm in exponential form and it's not helping me, go to log form. And if I'm in log form and it's not helping me, then convert to exponential. So we're going to use this to evaluate. So to help us find log base b of y, ask yourself what power of b gives you y. So you could read, but let's just look at this right here. So if I convert this, log base 4 of 64 equals x. Make your swoosh. 4 to the x power equals 64. Well, that means x has to equal 3 because 4 to the 3rd is 6. Okay, let's try the next one, but before we do the next one, I want to rewrite this to help you. So log base 5, 0.2 is the same thing as 1/5. So let's rewrite this. Equals, I'm going to call it x. We're going to find x. So I make my swoosh like this. I have 5 to the x equals 1/5. Well, I need to send the 5 to the denominator, so that means that the x, or the power, needs to be a negative. I don't want to make the 5 get any bigger. I want it to stay a 5, so it's going to equal -1. I'm going to call it x. Log base 1/5 of 125 equals x, and make my swoosh. So 1/5, the whole thing raised to the x power equals 125. I need to flip the 5 to the top, so it's going to be a negative. And 5 to the 3rd is 125, so -3. log base 36 of 6 equals x. Make your swoosh. 36 to some power equals 6. This one's a little bit trickier, and what you can ask yourself is, what do I want to do to 36 to make a 6? Well, the square root of 36 is 6. And to write the square root as a power, it's 1/2. I'm going to go up top and help you with this. If I want to take this and rewrite it in exponential form, it's 36 to the power over the root. This is 36 to the first power, and that's the square root. So that's where I got my 1/2 answer from. 4. Okay, there are lots of different kinds of logs, but there are two that we use all the time. The common logarithm has a base of 10, so we write log base 10, which if you ever just see the word log with no base, like log x, it's implied the base is 10. We also have what's called the natural log. It uses that thing e that we learned about in a previous video, e, which is 2.71 forever. And instead of writing log base e, we write ln. So we write ln x. And that means its base is e, which is the same thing as writing log base e of x. So on your calculator, there's a log button, and sometimes there's an ln button. But on your 4-function calculator, that's probably all you have. So let's practice entering these into our calculator, and let's round to 3 decimals if needed. So go ahead and do these problems just by entering them in your calculator. So just by entering those in your calculator, those are the answers that you should get. Okay, we started out this whole discussion by saying that logs and exponentials were inverses. And if they're inverses, they undo each other. So from Algebra 2, you should remember that if something is an inverse and you do composition, this thing or this thing, they are inverses if and only if, when you do this composition, that you are left with x both ways. So if you look right here, the key here is the base is the same. So this is an exponential with base b, and the power is a log with a base b. Since an exponential or the log undo each other, and those bases are exactly the same, they will undo each other, leaving you with a resultant of just whatever was laying right here, which is x. Same idea. Here's a log with a base b, and the thing I'm taking the log of is an exponential with a base b. Those two things will undo each other and leave me with whatever the power was right here, which is x. So let's look at the one given. So right here, I'm going to write this 10. It says log. What that means is log base 10 because it's implied. It's a common log, 4. So 10 raised the power of log base 10 of 4. So my exponential has a base of 10. My log has a base of 10, so they will undo each other, leaving me with this right here. So my answer is 4. Let's try the next one. So let's rewrite this. Those don't match. So I'm going to write this as log base 5. 25 I can write as 5 squared to the x. And let me write that one more time. Log base 5 of 5. I can multiply the 2 and the x together to get 2x. So I have a log with a base of 5. The log is taking the value of an exponential with the same base, which results in whatever's up here. Just that 2x power. Couple other log properties. Log base a of 1 is always 0 because anything the 0th power is 1. And I need you to add one little thing here. A cannot equal 0. Log base a of a equals 1, because a to the first is, and there's a typo right here, a. And this is that one-to-one property that we learned about in the last section. If log base a of x equals log base a of y, then x and y must equal each other. So let's try this example. The hiding base here is 10. The hiding base here is 10. The bases are the same. That's very important, which means or implies that from the one-to-one property, 2x plus 1 must equal 3x. Subtract the 2x over, and 1 equals x. So we can use that one-to-one property to solve. Okay. I'm going to just have a little thought bubble right here. So if these are inverses, then this thing's inverse should be that y equals a to the x. So I'm going to graph that inverse. So if you remember anything about inverses from Algebra 2, they reflect over the line y equals x. So if that was my exponential function, then my log function that I have right here should reflect over that line. And instead of having, before I had this horizontal asymptote that went like this, now I have a vertical asymptote that goes up and down like this instead. So the domain is going to be what's restricted. In this case, it's going to go from 0 to infinity. Our range is what becomes negative infinity to infinity. And this thing's intercept was 1, 0. It has an x-intercept. So this is a one-to-one function, so it has an inverse. And then the same transformations that we had before still are going to apply. Just like they did with the exponentials. So let's go ahead and try to make a log graph from scratch. So we're going to do some clear-cut steps, and maybe it'll help us out. So you have y equals log base 2 of x. And that's probably not very helpful for you to graph, so I'm going to start at my base, and I'm going to swoosh again, remember, towards the equal sign. So if I start this way, my equal sign's this direction like this. That results in me now having 2 to the y equals x. That looks very funny, because the y and the x are in the wrong places. So I'm going to flip them to make my life easier. And as long as I unflip them, it's fair game. So now I can make a table. Here's my x and my y. So let's pick the same ones we used before. Let's do -1, 0, and 1. If I plug in -1 for the x, I get 1/2. It flips the 2 to the bottom. And into the 0th power is 1, and 2 to the first is 2. But remember, I switched the x and y, so I have to do this last step right here, and I have to trade them back. So this is going to be my y, and this is going to be my x, and now I'm going to graph them. At 1/2, I'm at -1. At 1, I'm at 0. And at 2, I'm at 1. There's my log graph. That was a pretty simple example, so let's try a trickier one. Okay, so we have to make our loop, but make a little note right here. Your little note is that you first have to isolate the log. So if I have y equals 1 plus log base 2 of x plus 1, the log's not by itself. I have to subtract that 1 over. So I get y minus 1 equals log base 2 of x plus 1. Now I'm going to make that swoosh like this and get 2 to the y minus 1 equals x plus 1. And then again, before you trade, isolate. So I need to subtract the 1 over. So I have 2 to the y minus 1 equals x. Now trade. So 2 to the x minus 1 equals y. Okay, let's pick some things to plug in. This time, I don't think -1 is a good place to start. I'm going to start at 0, 1, and 2. And that's because I'm subtracting 1 in the power, so I don't want that to get difficult. So if I plug in 0, 0 minus 1 is -1. The 2 becomes a 1/2. 1/2 minus 1 is -1/2. If I plug a 1 in the power, 1 minus 1 is 0. 2 to the 0th is 1. 1 minus 1 is 0. If I plug a 2 in the power, 2 minus 1 is 1. 2 to the first is 2. And 2 minus 1 is 1. And then don't forget, trade them back. Y, x. So at -1/2, I'm at 0. At 0, I'm at 1. And at 1, I'm at 2. This thing shifted. And do you see this right here? This +1 means that I went to the left 1, which means my asymptote is left 1, or x equals -1. It's a vertical asymptote, not a horizontal asymptote. There's some practice for you to do, but I want to take your attention to this problem in particular, and it's this thing right here that I'm most worried about. Before you do anything, you need to do a little bit of algebra. Y equals log base 3. Be very careful, pull the negative out, and then call it x plus 1 so you see which way you really end up shifting. Because this way, I'm afraid here you're going to tell me that you went to the right, but really this is going to go to the left. So just be careful of that when you're graphing. So if I do my swoosh, I get 3 to the y equals negative x plus 1. I'm going to divide the negative over, so I get -3y equals x plus 1, and then -3 to the y minus 1 equals x. And from there, you can make your table and graph. Hopefully that helped you out a little bit.